In doubts, we take up doubts asked by students on different forums, the Facebook group or a Telegram group. Interesting ones. So this is a decently interesting one. ABCD is a rectangle with AB 22, BC 12. So the length breadth are given. DEF is a triangle. Remember D is going to be a vertex of the triangle. E and F we do not know, is inscribed in the rectangle such that E lies on AB and F on BC. Given that DE is 15, find the least perimeter. This is the part that makes this question interesting, the least perimeter. So I would ask you to go ahead, give it a shot. There's no point in just watching the video, students. Here you should always have an idea of it, the difficulty level or what challenge it poses to you. Only then it will make sense. Hopefully you have given it a good shot. I'm continuing. ABCD rectangle. So AB, I know the dimensions, and D, E lies on AB. I don't know where it lies, so let me take 1 point wherever E, and F on BC, F on BC, and this is the triangle whose perimeter I want. I know DE is 15. But I do not know EF and I do not know DF. Once I know this, the perimeter can be found. The other data, coming to what is known to me, BC is 12, so this is 12, 12, 15, right angle, 12, 15 right angle. This will obviously be 9, 9, 12, 15 is a triplet. I know AB is 22. So if I know this 22, I know this is going to be 13. Now 13 also is a triplet part, but then this is not the hypotenuse. So ignore 5, 12, 13. That should just come to your mind and you should ignore it because 13 is not the hypotenuse. So how do I minimize the perimeter? And unknowns are DF and FE. So you can't do anything about DE. It is going to remain 15. So you need to minimize DF or rather EF plus DF. Now minimize some math relation you can get. So probably there are right angle triangles. So I probably need some variable, and once I get a variable, I can find these lengths and then I need to minimize. So you can take a variable x. The moment you take x, EF, you know, EF is going to be root of x square plus 13 square plus DF. Now you also know DF. Why? Because this is 22 and we know CF now. How is CF known? CF is nothing but 12 minus x. So DF is going to be root of 12 minus x the whole square plus 22 square. Now this is the distance that we get, and we need to minimize this. So this is the challenge. So those who love maths, a lot of work they do with pencil work, they'll say, okay, I've solved it now, I just need to minimize it, and which is true. Except that minimizing this is a tough part. I don't think so we would have a lot of competence in minimizing terms which have a square root in them. There is a very classic way, but that is for some other lecture. You can use derivatives, surely. You can take the first derivative of this, equate it to 0, get a value of x and plug in those values of x, and that might be either the maximum or the minima. You can find the second derivative to know whether it's maxima or minima. There are students who will do it, but 2-3 problems. One, you need to know derivatives for that. Second, even if you know, it is very, very time consuming, and let's say even if you devote time, it is very tedious procedure, right? So I should look at some interesting solutions. So I'm going to discount this whole process itself, right? Yes, I say you can solve it that way, but then it's not very interesting. So how do I make it interesting to solve? Pay attention to this. In fact, the general idea is you have a line. Pay attention to this. This is the line. You have two fixed points, D and E. Right, now this F point can move. F point can be anywhere on this line, and I want the sum of these as least. That is the general idea. Okay, and the way to handle it is take the mirror image of any of the fixed points. Any of the fixed points. Okay, I'll take the mirror image of D. So about this line, okay, about this line. So you take the image of D about this line, so it will go perpendicular to this line. Whatever length you have here, that same length you go here, 22. And because it's a reflection, I'm going to give it a name D dash itself. Now, if I join FD dash, then DF is going to be exactly equal to D dash F. And why is that? That is because these two triangles are going to be congruent. That is the idea of reflection. These are congruent. Why? Because it's 90, 90, 22. By construction, this is 22. I took it at a reflection, and CF is common. So both triangles are congruent. DF is equal to FD dash. Now, so we need to minimize. We needed to minimize EF plus DF, and now this DF is nothing but D dash F. Okay, and so we need to minimize this. And EF plus FD dash we need to minimize. That is as simple as, now this F point could be anywhere. It could have been up also. It could have been down also. So it could have been any of these. Now, which is the minimum point? So when we need to add them, these are two segments. Obviously, the minimum is when this is a straight line. When this is a straight line, that is, so this F is going to be the one which gives me the minimum value when I get EF to be a straight line. Okay, because when they are collinear, that is the time I'll get the least value. If you take any other, it is going to be sum of two sides of a triangle, which will be greater than the direct distance between them. So EF and FD, when I add them, FD dash, which will be same as this length. Okay, so that's it. So I don't think so there's a lot left here. How do I find ED? By taking, extending this 22, 13 and 22. 13 and 22 make it a 35. And this is 12. And this is a right angle triangle. Okay. And so if it is a right angle triangle, the hypotenuse, again there's a triplet. But what is the triplet this time? 12, 35, 37. So 37 is going to be this. The minimum value of this is 37. So what is the minimum perimeter? Minimum perimeter is going to be 37 plus the 15, the third side 15, which is going to be 30, 40, 52 is the answer.